Hello, students. I am Madhuri, your maths teacher. I will teach you 9th standard maths today. That is CBSE syllabus. First lesson is number system. Two parts are over. Today, the third part. So, today we will learn about real numbers and their decimal expansions. Real numbers and their decimal expansion. That is part 3 of number system. We will solve exercise 1.3 questions 1, 2, 3 and 6 and some examples also. So real numbers and their decimal expansions. So the decimal expansion of a rational number is either terminating or non-terminating repeating decimal. So this we will learn in part 2. The decimal expansion of an irrational number is non-terminating, non-repeating. So we did more problems on these 2 points. The decimal expansion of a rational number is either terminating or non-terminating repeating decimal. The decimal expansion of an irrational number is non-terminating, non-repeating, non-recurring decimals. So in that second class we learn about terminating decimals and non-terminating repeating decimals and non-terminating non-repeating decimals. So examples of non-terminating non-repeating decimals are 0.10, 110, 1110, etc. So this is terminating decimal, non-terminating repeating decimals and non-terminating non-repeating decimals. I will terminate means to end or stop. Here 1 by 8 is 0.125. It stops here. 1 by 2 0.5. 1 by 4 0.25. So these are terminating decimals. So it has a stop. But repeating decimals, non-terminating, repeating decimal. Non-terminating is no stop and it is repeating. 2 by 3 0.6666. There is no stop and 6 is repeating. 3 by 11 0.27272727 is repeating and it do not have any stop, so non-terminating, no stop and repeating decimal. 11 by 6 is equal to 1.8333. Here 1 and 8 are not repeating but 3 is repeating, so this is also a non-terminating repeating decimal. So terminating decimals and non-terminating repeating decimals are rational numbers. These two are rational numbers. The other one non-terminating non-repeating decimal. So this is an irrational number. Here root 2 1.414213 562373 It is there is no end and no digit is repeating and it is not terminates, no end. So non-terminating, non-repeating decimal. Same way root 3 is also non-terminating, non-repeating decimals. Pi is also non-terminating, non-repeating decimals. So non-terminating, non-repeating decimals are irrational numbers. Terminating and non-terminating repeating decimals are rational numbers. Find the decimal expansion of 10 by 3, 7 by 8 and 1 by 7. So 10 by 3, 10 divided by 3. In 3 times, uh, you can find 3 times 3 in 10. 3 3s are 9. Remainder 1. So after 10, you can put decimal point and many zeros. So 10 minus 9 is 1. Next is decimal point. I will write the decimal point on the top in the quotient. Now I will put 1 0 down, 10. Again in 10, 3 times 9. Again remainder 1. Again 1 more 0 down, 10. Again 3 times 9. So it will repeat. Go on forever. So 10 by 3 is equal to 3.33333. But 7 by 8, after 7 I will put decimal point and you can write many zeros. So 7, 0 times 8 in 7. So I will write 0 on the top and next is decimal point, that also will write up. then 0 down, so together 70. In 70, how many times 8? 8 times. 8 8s are 64, remainder 660. How many times 8? 7 times 56, remainder 4 40. How many times 5 8s are 40, remainder is 0. 0 means it ends, stops, so it's a terminating decimal. 7 by 8 is 0.875. Now 1 by 7, 1, see, you will get 0.142857. See this process, again here you got the remainder 1. That means this whole process will repeat. This process will repeat. So that means 1 by 7 is 0.142857, 142857, 142857. It will go on repeating. Next one, show that 3.142678 is a rational number. In other words, express 3.14267 in the form P by Q, where P and Q are integers and Q not equal to 0. This is a terminating decimal, it stops, end. So that means a rational number. But here you have to prove that, show that. That means you have to find the P by Q form of 3.142678. So here, after the decimal point, how many decimal places you can see? 1, 2, 3, 4, 5, 6. 6 decimal places. That means the denominator we will put 1 and 6 zeros. That means 1 million. So here we ignore the decimal point and write all the digits. That means 31 lakh 42,670 divided by 1 million is the P by Q form of 3.142678. We have 3.142678 is equal to 31 lakh 42,670 by 1 million, and hence is a rational number. Next question, show that 0.333 etc. O is equal to 0.3 bar can be expressed in the form P by Q, where P and Q are integers and Q not equal to 0. Solution. Since we do not know what 0.3333 is, so 0.333 etc. means 0.3 bar. So let us call it x. So x is equal to 0.3333 etc. Since one digit is repeating, we multiply x by 10 to get 10x is equal to 10 into 0.3333 etc. So when we are multiplying the left hand side by x, you have to multiply the right hand side also by x. We can multiply the left hand side and right hand side by the same number. So here 10. So 10x is 10 into 0.333 etc. So multiplying by 10 means 1 0 in 10. So we will shift the decimal point 1 places to right side. So you will get 3.333 etc. So 10x is equal to 3.333 etc. So this 3.333 etc. we will write as 3 plus 0.3333 etc. That means 3 plus x, since x is 0.333 etc. So how we got this 3? We will subtract x from 3.3333. So 3.3333 etc. minus 0. That x is. So here this I will write here 3.333 is equal to etc. is equal to 3 plus x. So 3 is left hand side minus 3. Left hand side is 3.333 etc. minus x. X is what? 0.333. Okay. Now decimal points should be on the same column. Now whole number part you can subtract first. 3 minus 0 is equal to 3, and after that decimal part. Decimal parts are 3.333 etc. up to infinity minus 3.333 etc. up to infinity. Infinity minus infinity we don't know, but it is very close to 0 because 0.000000000 like that. So that means it is very close to 0. So we will consider this as 3. So 3 plus x. 3.3333 etc. is equal to 3 plus x. X is equal to 0.333. So now, therefore, 10x is 3.333 is 10x. 10x is equal to 3 plus x. Now we will solve for x. Here x is added, so we will subtract x. Solving for x, we get 10x minus x is 3. What is 10x minus x? That is 9x. 9x is equal to 3. Now what is x here? 9 is multiplied. So we will divide 9. Therefore x is 3 divided by 9. 3 and 9 both are divisible by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. So 1 by 3 is the p by q form of 0.3 bar or 0.333 etc. Next one show that 1.2727 etc. That means 1.27 bar. 1.27 bar can be expressed in the form p by q where p and q are integers and q not equal to 0. Solution. Since we do not know what 1.27 bar, let us call it x. So x is equal to 1.27 bar. That means 1.272727 etc. How many digits are repeating? 2 digits. So we will multiply by 100. Since 2 digits are repeating, we multiply x by 100 to get 100x is equal to. We will multiply the left hand side and right hand side by 100. 100x is equal to 100 into 1.2727 etc. So multiplying by 100 means 2 zeros. So we will shift the decimal point 2 places to right side. That means 127.2727 etc. So 100x is 127.2727 etc. So 127.2727 etc. can be written as 126 plus x since x is 1.272727. How we got 127? We will subtract x from 127.2727. See 127 this one 127.2727 etc. is equal to 126 plus x. So 126 we will find how we will find 126 1.2727 etc. minus x. So x is 1.2727 etc. So 127.2727 etc. minus 1.2727 etc. These decimal points are on the same column. 127 minus 1 is 126. So first we will subtract the whole number part. Whole number part is 127 and 1. The difference of 127 and 1 is 126. Now decimal part. 272727 etc. minus 2727 etc. up to infinity. So infinity minus infinity. It is very close to 0. So we will consider this as 126. 127.00000 will consider as 126. So 1.27 127.2727 etc. is equal to 126 plus x. So 127.2727 etc. is equal to 100x. 100x is 126 plus x. So now we'll solve for x. Here x is added, so we will subtract x from 100x. Solving for x, we get 100x minus x is 126. What is 100x minus x? 99x. 99x is 126. Now 99 is multiplied to x, so we will divide 99. We will divide 126 by 99. So 99x is 126. So x is 126 divided by 99. Now 126 and 99. Both are divisible by 3. 126 divided by 3 is 42. 99 divided by 3 is 33. Again, 42 and 33 both are divisible by 3. 42 divided by 3 is 14. 33 divided by 3 is 11. So 14 by 11 is the P by Q form of 1.27 bar or 1.272727 etc. Show that 0.2353535 etc. is equal to 0.235 bar can be expressed in the form P by Q, where P and Q are integers and Q not equal to 0. So here, since we do not know what 0.2353535 etc., let us call it x. So x is equal to 0.2353535 etc. That means 0.235 bar. X is equal to 0.235 bar. How many digits are repeating here? Two digits are repeating. So since now the block 35 repeats, that means two digits are repeating. So we will multiply x by 100. X by 100 means left hand side by 100 means right hand side also by 100. We will multiply the left hand side and right hand side by the same number. So left hand side is x, x into 100, 100x. Right hand side is 100 into 0.2353535 etc. means we will shift the decimal point two places to right side. Two places to right side means you will get 23.535353 etc. So 100x is 23.535353 etc. So now 23.53 bar is equal to, this is equal to 23.3 plus x. X is what? 0.2353535 etc. or 0.235 bar. Since x is equal to 0.235 bar. So we will write 100x. That means 100x is 23.535353 etc. That means 23.53 bar. We will write 23 point, the right hand side as 23.3 plus 0.235 bar. From where did we get 23.3? We subtracted 0.235 bar from left hand side. 23.53 bar. See 23.53 bar. 535353 etc. minus 0.2353535. Decimal points on the same column. Whole number part minus whole number part. So 23 minus 0 is equal to 23. Now decimal part. First it 5 and 2. 5 minus 2 is 3. Then 35, 35, 35. Here also 35, 35, 35. Infinity minus infinity is very close to 0, 0, 0, 0, 0, 0, 0, 0, 0. So we will consider this as 0. We will get 23.3. So 23.50 can be written as 23.3 plus 0.235 bar. So 100x is 23.3 plus x. So now we will solve for x. So we will subtract x. We will take the left hand side, that means plus sign will become minus sign. 100x minus x is 23.3. 100x minus x is 99. 99x is 23.3. Here you can see one decimal place. Remove that decimal point. How we will remove the decimal point? We will divide 233 by 10. Okay, so now there is no decimal place. Here one decimal place means in the denominator 1 followed by 1 0. Now 99x is 233 by 10. So what is 6? We will divide by 99. So 233 divided by 99 into 10, 990. Or 233 by 10 divided by 990 is 233 by 233 divided by 10 divided by 99 is 233 divided by 990. So x is equal to 233 divided by 990. So we cannot, this is the p by q form of 0.235 bar. Find an irrational number between 1 by 7 and 2 by 7. We saw that 1 by 7 is equal to 0.142857 bar. So what will be 2 by 7? 2 into 1 by 7. So that means 2 into 0.142857. You will get 0.285714. Now you have to find an irrational number between these two. So first two decimal places 14 and 28. So between 0.14 and 0.28 you can find many irrational numbers. So to find an irrational number between 1 by 7 and 2 by 7, we find a number which is non-terminating, non-recurring. So non-terminating, non-repeating, lying between them. So of course you can find infinitely many such numbers. An example of such a number is 0.15. So 15 is between 0.14 and 0.28. 0.150, 1500, 15000, 1540. So the decimal expansion of a rational number is either terminating or non-terminating, repeating, recurring. The decimal expansion of an irrational number is non-terminating, non-repeating.